Hello, hello. Who's excited for trustless today? Wait, like maybe one more coffee. Who's excited for trustless today? All right, thanks guys, thanks guys. My name's Britt. I'm really excited to be emceeing today. And first up, we have Yoav Weiss, EF researcher, head of the account abstraction team, and co-author of the Trustless Manifesto. And he's gonna be talking about making Ethereum feel like one chain again. Big round of applause for Yoav Weiss.
Hi, good morning, everyone. Sorry? Yeah, talk to Marissa about that. Okay. Yeah, so today I'm going to talk about, so in this talk, I'm going to talk about making Ethereum feel like one chain again. And it's, this talk is not going to be very technical. It's about the vision behind EIL and not a deep dive into the protocol mechanics, which we're going to do later in the day. It's mostly about what it enables and why it matters. So how many of you here used the internet before the mid-90s? Right? That's even more than I expected. Yeah. So, but many people in this ecosystem were not even born then. So, I used it, and it wasn't great to say the least. I mean, it was very innovative, but usability was lacking. And the main thing that made it difficult was that each server and each protocol were an island. So I could telnet to a server and use it in various ways. I could FTP to a server and download a file, or I could go to an IRC server and chat with my friends. We even had Gopher, which looked a little bit like a website, but it was always local on one server. So there was no composability. No way to move between the apps. Like if I can download the file and then I can then I can switch to another app, and I can switch to another app and go chat about it, but not in one place. And the friction of moving between them was quite high. I would have to switch an application on my computer, just like move between between Telnet or FTP or an IRC client. And I would have to re-authenticate myself. So I have to authenticate myself separately to each server. And then it has a single use. And the app has to do everything. It does not combine functionality with other apps. Then HTTP changed everything. One of the great things that HTTP did is to abstract away servers. So we can have one application can span across different servers. It could load an HTML, it could load the content, text content from one server, and then load the pictures from another, and then even code, like JavaScript libraries that come from various servers. And later we even started seeing specialized services running on different servers, such as you could have a secure payment server for which enable e-commerce, and you don't have to implement your own payment system in every website. And we even got identity with OAuth, meaning servers can, meaning that you can have your identity in one place and use it to authenticate to many different apps on different servers. We had video streaming services, so this really made the web what it is today. And what ties it all together is the browser. The browser is the user agent. This is the user agent for everything. So now we have one application and infinite use cases instead of having one application, one use. So now going back to Ethereum. So rollups helped Ethereum scale. This has been Ethereum's scaling strategy is based on having rollups, on having layer 2s. And it's great. We now have abundant block space spanning across different layer 2s, but we broke UX. So now for each L2, you can use it with reasonable convenience, like you would, at least like you would Ethereum L1. But once you need to move between them, we have a high friction. So we need to switch to another RPC. We need to bridge our assets. We need to configure various things. We have there's very high friction in switching between them. So we don't see a lot of applications that combine things that live on different chains, which is unfortunate since one of the things that we've been seeing is app chains. So we have a chain that hosts a single application, but then the friction of using this application is quite high. And so we need to solve this problem of rollups feeling like an island and make it feel like one chain. The process nowadays is if I want to I want to do something on a different chain, I need to sign a transaction in my wallet. And then I need to sign a transaction which sends assets or something to a bridge. Then I need to wait for the bridge, which is often a trusted bridge. I send my assets to someone and I wait, and then I'm prompted to switch to another network in my wallet, and maybe I need to configure that network if I haven't used it before, and then I need to sign yet another transaction on the new network to do something. So that's not what Ethereum should feel like. It feels a lot like the days before HTTP. It was all manual, error-prone, and quite frustrating to use. So our vision is to have Ethereum feel like a single chain across all L2s. And what this requires is using one signature per operation, not per transaction on each chain. If I'm running something that involves 5 different chains, I want to see a list of what I'm doing. I need a clear signing, but I want to see the list, to sign it as a single operation, and then my wallet should take care of the rest. And I also want to pay gas once, because maybe I don't hold ETH on all of these networks. I have it only on one. I want to pay the gas for all of these for my transactions on all of these different networks. I want to be able to use my funds, my assets everywhere. I don't want to care about whether my assets are on Optimism or on Arbitrum. I just want to use them. And we want all this to work with the same security and trust assumptions. We want to give, Ethereum is all about censorship resistance and trustlessness. So we want to solve the UX problem, but not by compromising and having a weaker censorship resistance, for example. And so this is the experience that we are building. It's let's say Alice wants to send Bob. So Alice on Arbitrum wants to send USDC to Bob on Base. She signs once. There is no bridge. She doesn't even know that he's on another chain. She just pastes Bob's address, which contains all the information that the wallet needs in order to know how to get there. And then she clicks send, and Bob Bob receives the funds immediately. Now, Ethereum is not just about transfers. It's about Ethereum was built to run dApps. We want the decentralized applications running. These are smart contracts. You want to send transactions to them. So we want it to be equally easy and equally trustless to make calls with a single operation on multiple chains. And this happens again with one signature. So let's say Alice lives on Arbitrum and she wants to mint an NFT on Optimism, but she doesn't have ETH on Optimism, and still she only signs once, and her wallet takes care of everything. So her wallet sees that she has ETH on Arbitrum. It enables her to use the ETH on Optimism, both for paying the gas and for buying the NFT. And she just receives the NFT instantly back on Arbitrum. So that's like one click, one signature, and the wallet executes the operations everywhere. So HTTP unified the web and made what it is today, and we think that EIL could do the same for Ethereum. You'll be able to use your wallet your wallet becomes like the browser in the mid-90s, where it allows you to compose the functionality from all the different chains and use it with one UX. You never have to switch. You never have to bridge, and that's just work. And most importantly, we are preserving Ethereum's core value, which is to also give you censorship resistance, self-custody, and all of these important traits. One way to look at it is to compare centralized exchanges to decentralized ones. So everyone here use centralized exchanges. And they're generally convenient, but they require trust assumptions. You need to send your assets to a third party that lives off chain. You basically send it to a server, and then you swap or you do whatever with the assets, and finally you can withdraw it back to the blockchain, assuming they let you. And then if they go down, they become unavailable, or maybe something along the way becomes unavailable, like this morning Cloudflare is down globally, and maybe you're not able to use your centralized exchange, so now you don't have access to your assets. Now compare this to DEX. So in the centralized exchange, you swap directly on-chain. It's self-service. You don't have a counterparty off-chain. So you retain self-custody. You hold your assets, and then you send them to a smart contract, which instantly, within the same transaction, gives you the other asset. So if we look at interop today, at bridges, relays, solvers, they resemble a centralized exchange. You also send your funds and your calls to another. You send them to an off-chain server. Now you have this off-chain entity that's supposed to be your agent and act on your behalf. But maybe it doesn't have your best interest at heart. It is a third-party server operated by someone else. So you submit your funds and your calls to someone, to an intermediary. The intermediary runs some off-chain logic. Often you don't know what exactly it's going to do. It determines how to best fulfill your intention. And then it submits transactions on your behalf at the destination. Now, compare this to EIL, which I'm going to talk about. So with EIL, you submit your own transactions everywhere. Nobody ever submits a transaction on your behalf. It's self-service, just like a DEX. You retain self-custody because funds are moved atomically, similar to atomic swaps. And there's no middleman involved. So EIL is account-based interop. It means that it puts the wallet in the center. EIL lives locally. It runs locally on your machine inside your wallet, and not on a remote server. You don't delegate anything to a server that does something on your behalf. Users perform their cross L2 operations themselves. Now, you can execute yourself, but you still need to pay for the gas and to move liquidity from one place to another. So you need someone's help. We have, in EIL, there's something called an XLP, a cross-chain liquidity provider. But the XLP, this liquidity provider, it never acts on your behalf. It will never transact. It doesn't know what you're going to do on each chain, and it doesn't do it for you. What it does is it sells you a gas voucher or asset voucher, which is it's a form of an atomic swap. You send so the only information you expose, which is all on-chain because there are no off-chain interactions, the information you expose is you say, I need to use 100 USDC on this other network. So I want to use 100 USDC, and I need to pay a certain ETH amount for gas. That's all you have to reveal. And then permissionless liquidity providers compete on-chain on giving you a voucher, and they get a fee for it. So you get this voucher, and now you use it yourself. You put it inside your transaction for every destination chain you use, and the voucher is used to give you assets that come from this XLP's balance, which means that. So it works like an atomic swap. The XLP did not do anything. You executed the transactions on both ends, and the assets remain in your custody, because until they give you a voucher, the assets are yours. And once they give you a voucher, this voucher is, the only way they claim the funds is with this voucher, and the voucher is now used on the other side. The same message that they sent, that they had to sign in order to claim your fund, is the message that you use to claim theirs. So this allows us to retain Ethereum's core values, because you are censorship resistant because you execute your own transaction everywhere, so nobody can delay or stop your transactions. And you don't have to, so we don't introduce any trusted parties. There's nothing permissioned in the system. What does it feel like for the user? I mean, the user doesn't want to feel or to even know about all this. Just wants to use the network. So it's one click to do any operation, regardless of the number of chains. The user never sees different chains. You don't switch between them. You don't even know where the dApp lives. What it feels like is one Ethereum that just works. You use your assets everywhere, regardless of where they are, and you use applications regardless of where they're deployed. You can use contracts on any number of chains. You don't know which chain they are deployed on. So everyone wins. The users, developers, and the Ethereum ecosystem. For the user, it's a very smooth UX. You just so you can just sign something and everything works, and you don't need to add any new trust assumptions, any new security considerations. So for the user, it's a clear win. For the wallet, the wallet is empowered to become the user's multi-chain agent. It becomes a multi-chain native and does not add dependencies on third parties. So if you're a wallet developer and you add support for EIL, you can just you become the browser for the user on this new internet. And for applications, it's great because they become available to everyone. They are not. There's no friction in using application, so you don't need, when you develop a new contract, you don't have to start thinking, okay, where am I going to deploy this? You can deploy it in one place and it can be used from others without friction, which also saves you a lot of effort of doing interop plumbing. I mean, nowadays, if you want your dApp to become available to other chains, you have to do some work on the dApp side. With EIL, there's going to be a standard that extends the ETH send calls batching ERC. It extends with a new capability. allowing the dApp to just say, here is the list of things that I want to execute. Here's a list of calls that I want to execute on each of the chains. And that's it. The dApp doesn't know what EIL is. The wallet just gets this batch of, let's say, multi-chain batch, and shows it to the user, gets it approved and executed. And the whole ecosystem wins, because now it feels like one chain again. We have a unified Ethereum without giving up on a decentralization. So today we are launching a test. We are an experimental testnet. We released the experimental code. It's by no means mainnet ready, but we can already invite wallets and dApps to test it, to start integrating and experimenting with what it enables. And we'll only get to mainnet after getting some initial feedback on this, making improvements, and then of course getting an audit, because this needs to be secure. And then we'll get to mainnet. So now is your opportunity to imagine with one unified Ethereum, but with abundant block space and the smooth UX. What can you build? That now that Ethereum is unified? The HTTP enabled so many new use cases and made the internet what it is today. And it'll be interesting to see what people come up with, what builders can do when we have something equivalent for Ethereum. Yeah, so HTTP made the internet usable by everyone. Suddenly, my mother was able to use the internet. And EIL can do the same for the L2, for the Ethereum L2 ecosystem. So let's help users forget which chains they are on. Right. Thank you. Right, do we have any questions? Yeah. Oh, we have this.
We got fancy tools for this.
Sorry?
So there's actually been a QR code on stage all day.
Okay.
So we've got a couple good ones.
So did you send it? Okay, please.
All right, so if you can deploy on any chain seamlessly, would this not result in everyone deploying on L2s to save on deployment costs and no one deploying on the L1?
No, because L2s have, so each L2 has its own trust assumptions. They are not created equal. And luckily we have L2bit, which helps us know which chains we should use. And I think wallets should reflect that. So one part of the vision that I haven't talked about, because you can't cover everything in one talk, is that when we abstract chains and make the wallet discover it, the wallet should also be able to look up on-chain an attestation by an entity like L2bit that checks, is this a stage 1 rollup, stage 2, or maybe it's just some side chain pretending to be an L2. So the wallet should warn you, actually. And if you run a transaction, and let's say you just use $10, maybe you're going to be okay with that. You say, yeah, that's fine. I'm going to take this big risk on $10. But if you're going to send $10,000, maybe this warning will mean something to you. And I say, no, actually, I prefer to use a dApp that lives on a chain that is more secure, whether it's a secure L2 or in some cases even L1. So the user gets to choose. You need to inform the user, and that's the responsibility. I mean, the wallet gets a lot of new responsibilities here, and this is one of them.
Awesome, thank you.
Thanks.
I have one more, and just if anyone has any other questions, please feel free to scan the QR code that I'm sure will pop back up there in a moment, and you can chime them into the chat. Second question is, can you explain the difference, we got a couple coming in, between EIL and OIF?
Yeah, so the difference between EIL and OIF is intents versus transactions. So first we need to understand what's an intent, what's a transaction. Transaction is this imperative thing where we say exactly what should be executed where. It's like I want to execute this call data, I want to call this function in that smart contract. Intents, on the other hand, they are a high-level construct. With intents, you abstract it. You say what you want the end result to be, not how to achieve it, and then a solver will figure it out for you. The solver will know, like I say, okay, I want to have funds on that chain, or I want to have that NFT, and now a solver figures it out on your behalf, and they will get it done. It's very convenient. So OIF does intents, and EIL does transactions. And the reason we chose to do it this way is we wanted to create this transport layer, which you could actually build something like OIF on top. So we wanted to have this transport layer that doesn't let a third party interpret anything on your behalf. Nobody interprets your intention. You decide yourself what's going to be executed. But then, so you lose the convenience of having someone figure it out for you. Your wallet now needs to figure it out. Whereas with intents, you have this flexibility, but you pay with adding this external dependency. So there's room for both approaches. They just make very different trade-offs in terms of how you could, in terms of who do you need to trust.
Wonderful. All right, and so what if a transaction puts money on a chain not supported by the wallet?
So that's another part of the vision that I haven't covered here myself, but Marissa is going to talk about later. That's part of the vision requires multiple standards. One of them is chain-specific or interoperable addresses, where you have to send someone. So like when Alice sends to Bob on base, she sends actually to 0x1234 at base.eth. So that's how Alice does it to know about base. But what if her wallet doesn't know what base is? That's fine, because there's going to be an on-chain config. Every rollup can, and that's also something that we've been working on a standard for. So every rollup is going to have a standardized form of a config contract that has everything you need to know in order to start interacting with it, like the official RPC. And so you have the official RPC, the official bridge, official light client contract for verifying what this RPC tells you. So now when your wallet needs to interact with with a chain that it never heard about, it can get all the information from a contract on L1 that is registered to the ENS address or somehow associated officially by the rollup team. And that's how you can interact with any chain without knowing about it. Now, of course, it means since your wallet doesn't know what this chain is, and maybe this chain is actually like a fancy multi-sig, and you don't want to trust it with large amounts. So that's again why you need why you also need this attestation contract, where someone like L2Bit can tell you this network is safe to use, and if not, the wallet should warn the user about it.
Is the EIL only compatible with EVM-compatible L2s?
Yes, technically it could be implemented for other chains, but our focus right now has been EVM chains. That's what we implemented it as EVM contracts, because it also internally it uses ERC-4357, which is also built for it's also this account abstraction for EVM. So this remains a requirement for now. I assume that we'll see implementations of EIL for other networks, hopefully compatible ones, but we are not working on one right now.
Awesome. Let me see if we have anything else left in here. Also, anyone in the audience, please know you can upvote questions. So if you don't want to ask your own question, feel free to contribute to the popular vote. How can we participate in the testnet integration? Is there any doc link?
Yes, so I think we're going to talk about this later in the day, but we have a testnet on. We have it deployed on Sepolia in a couple of rollups, and we also and for the hackathon, since there's going to be a hackathon at ETH Global where we want people to build on it. It's easier to build on it's easier to build when you have actual real-life protocols deployed. So we have a test net. We have test nets for various rollups that are actually forks of their mainnet. This is hosted by Tenderly, and we have EIL deployed. We have XLPs running, so you'll be able to start experimenting with integrations as a wallet or as a dApp developer by using these mainnet forks of various networks and interacting between them.
Awesome. Thank you for your time today, Yoav. This has been amazing. I hope everyone's really excited about what we heard today. Can we give a big round of applause?
Thank you.